All right. This learning guide here is called Intersections of Lines, which is what we're going to be working with a lot. But really, we could call this systems of equations, because really what we're going to be working with throughout this learning guide is looking at what are called linear systems or systems of equations. So in this first section, first topic here, we're going to talk about what is a solution to a linear system. And by the end of this lesson, we'll understand, hopefully, what is meant when we say this term linear system. We want to be able to recognize what the solution to a linear system is or what it looks like. And ideally, we'll be able to, if we're given a linear system, we'll be able to figure out how many solutions there are to a linear system by looking at the slopes of the lines that are involved in this linear system. So to start with, let's go back and talk about a linear equation. A linear equation we've been working with for several years now. It's something like this: 4x plus 2 equals 10. And we know how to solve something like this. We use opposite operations, doing the same thing to both sides. 4x equals 8, and then we're going to divide both sides by 4 to get x is equal to 2. And x equals 2 is the solution to this equation. Now, what does it mean that x equals 2 is the solution? Well, it means that it's the value of x that satisfies the equation. And by that we mean if we look at the left side and the right side of our equation here, our left side is 4x plus 2, our right side is 10. There's only one value of x that when we sub it in for x, i.e. if we take x equals 2 and we sub it in here for x, we get 8 plus 2 equals 10. Our left side and our right side are the same. And x equals 2 is the only value of x that is going to do that when we sub it in. Any other value of x will give us a left side that is different from the right side, so it won't satisfy the equation. So a linear equation has only one variable, in this case x, but it could be any other letter, and our solution is the value of x that satisfies the equation, that when we sub it in, makes the left side equal to the right side. A system of equations, or a linear system, consists of two or more linear equations considered at the same time. So here we have a linear system consisting of the equations y equals x plus 2 and y equals 8 minus x. So notice we have two variables, x and y. Now there's a solution to this linear system, and the solution is the value of x and y that satisfies both of these equations. And we can write it as an ordered pair, x comma y. So the solution to this system is x equals 3, y is equal to 5. Okay? Or we can write it as the ordered pair 3, 5, or the point 3, 5. Okay. How did we get the 3 and the 5? Well, that's what we're going to look at in the rest of this learning guide, is different ways of finding that value of x and that value of y. But x equals 3 and y equals 5 is the only pair of x and y values that satisfies both of these equations. So for instance, if we take our first equation here and we look at the left side and the right side, our left side is y, our right side is x plus 2. If we sub in y is equal to 5, we get 5. If we sub in x is equal to 3, we get 5 as well, right? So left side equals right side. We can then do the exact same thing for our second equation. Left side, right side. Our left side is y. Our right side is 8 minus x. Y is equal to 5. 8 minus x is 8 minus 3, which is 5. So 3 and 5, okay, work to satisfy both of these equations. Now, we could pick a value of x and y that'll satisfy one of these equations. Like, there's lots of values of x and y that will work in our first equation here. So I could pick something like, let's use x equals, I don't know, 6, and y is equal to 8. Okay. When I do a left side, right side check for this first equation, okay, my left side is going to be my y value, which is 8. My right side is going to be x plus 2, 6 plus 2, which is 8. 6, 8 satisfies my first equation. But what happens when we try this with our second equation? Left side, right side. That's silly. I didn't set any of those other ones up like that. Let's do this. Left side, right side. Our left side is y, which is 8. And our right side is 8 minus x, which is going to be 8 minus 6, which is 2, which, notice, left side and right side are not the same. So there's a single value of x and y, single combination of x and y, that is going to work in both of these two equations. Okay. Now, one way of finding the value of x and the value of y that represents the solution to the system is by graphing the equations. Okay? And the point where the two lines intersect is the solution to the system, because this is the point, it's the only point that is on both of our lines. So in this graph here, we've got two lines plotted. We've got y equals negative 2x plus 8. It's negative 2x plus 8 is this line here. And then we've got the line y equals 2x plus 4. Sorry, minus 4. Okay. The solution to the system is the point where these two lines intersect. This point here, 3, 2. Okay. Or x equals 3, y equals 2. Okay. There are a lot of points that will work, like this is the only combination of x and y that is going to work when we sub it into both of these equations. There are other points that will work on one of these equations, like any point here, 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 like any of those points will work when we sub them into y equals negative 2x plus 8, but they won't work when we sub them into the other equation because those are points that are not on that other line. Similarly, points like, I don't know, 4, 4 and 5, 6 will work when we sub them into this equation because they're points on the line, but those points are not on the other lines, so they won't work when we sub them into the other equation. So there's just this one point, 3, 2, which is going to work when we put it into both of those equations.